Okay, let's start. Hello and a warm welcome from my side. My name is Philip Osterwalder. I'm the CEO and co-founder of OneLimbs. And today we have a special guest. We have Roger Schilbert from Aurovis. He is in our expert board and he is an expert in automation, robotics, and vision processing. Thank you very much, Roger, that you will share some insights and thoughts about lab automation, and also a welcome from my side.
Hello, everybody. Also, warm welcome from my side. And I'm happy to have some information for you, for innovating you in your lab.
Thanks for the quick introduction. So again, a warm welcome. And let's give some general information. So we will record the session. If you want to have reviewed or need also the presentation, which you see today from Roger on my side, send a request and we can forward it to you. Afterwards, this video is also on demand available to rewatch. If you have any kind of questions in between, just type it in the chat, or let's wait for the Q&A session at the end. And then you can ask directly Roger or me with your belongings or questions. So to have an overview about today, the webinar, we will tackle and explain some challenges in the lab automation, best practices from Roger's side about lab automation and how to implement and process successfully and beneficially lab automation. And at the end, what's the improvement and what's the benefits and the added value of some automated workflows in the laboratory. So directly, let's hop on to what we face as OneLimbs every day in some labs. So there are a variety of different kind of laboratories. If we talk about this laboratory, which we use for lab automation, is probably not only high sample throughput, is more about the routine workflows. So instead of copy and pasting, or even for some value adding workflows, which can be also automated. And we face a couple of main challenges every day. So there are a lot of error-prone and complex processes in the laboratory that can be organically grown and very difficult to automate, because they are not only a straightforward or streamlined process and workflow. It's more about the network of different decision makers and systems and data sources and even formats. And this makes it very difficult to get efficient process or workflow into an automation. The same is for fragmented or unstructured data. So different sources, different data structures, formats, which has to be converted on a format that is also be available to evaluate and elaborate this data. And are they annotated? So is the source, a single source, is this available too? The next point is more insufficient about silo data, insufficient connected and isolated data, so that there are a variety of different systems which can be used as a single source, but are not connected. This makes it difficult. I need a lot of skills and intro about this. Next point is the lack of control over the data itself. Where the data coming from? Are there any changes on the data? What's the change control? What kind of devices it used to get to a result? Metadata is a big topic about this. And also the data flow, where it comes from, where it should go, in which kind of format. This is also kind of a big problem in a lot of labs. And also the traceability, for sure. So the compliance, and also to track back about the different data and also the results of the workflow itself. We can see also some examples about raw data sheets and different kind of spreadsheets, Excel spreadsheets, and a variety of different Excel sheets that are highly used in different kind of laboratories. So maybe you also face the problem or issue that the lab is mostly a heterogeneous zoo about different devices. And it's not only makes sense, not every time it makes sense to connect all of these devices, but some of them kind of cost efficiency analysis, it can be determined which kind of devices, lab devices, make sense also to connect and to streamline the workflows and to get a fully automation about this. What we also think of is to break down the processes in different steps and think about what kind of mega breaks, what kind of difficulties and challenges are in my main laboratory workflows or even methods. What we can think of is what we are doing is kind of assessment before we starting an automation itself. So this is kind of a SIPOC based on Lean Six Sigma tools, where we elaborate and quantify the workflows and then determine if it makes sense to integrate, to connect, and automate these workflows based on the quantification and the time which is used within these workflows. And then we can detect and elaborate the bottlenecks about this. If there are time-consuming lab processes with some different data, or if it's more about media discontinuities, which needs a lot of time from copying on a USB stick and get it to another system and creating reports sent out of it, or something like that. Or is it more about the manual processes that have to do, that are kind of routine, donkey work, let's call it, or even monkey work, that has to be done day by day in the laboratory, which can be optimized within connecting different systems, which also what we provide as OneLIMS. And what is also very important is to define the KPIs of the lab itself, not only on the department or the company, more to break it down to get to know what kind of system are in use. What kind of numbers does the lab produce? How many employees, how many samples or analyzes, how much time it needs to do a specific analysis, how much analysis go externally. And you can see now on the slide, this is an example, real life example from a client from us about the evaluation. This is what we are doing before we do a digitalization and automation in a lab itself. And then the evaluation gets to start the calculation about the data management. And what we see is that roughly between 30 and 50% of the effective time in a laboratory as lab technician is using for data management. And this is, from our perspective, is burning money, because that's not what the lab technician has to do actually, because the real work is to do more analysis, to approve products, produce quality, or even to get more results, to create a report and to send this report to clients. This is what actually should be doing a lab technician and need less time for data management. And at this example, we calculated this together with the client to get also an ROI about the investment and what they get back. And what we can show here in this real life example is that 75% for 3 FTEs are used of their effective time for quality data management, for all of this sample and handling. And this is roughly 30,000 euros per year, what they spend on just data handling. And we can show also with the testing phase and implementation of our OneLIMS platform that we can dramatically reduce this effort in data handling and then automate this value adding and also routine workflows. This was a very short intro about what we are doing before automation. And right now I would give the word to Roger to give an example and an introduction about what Arobis is doing, what are his expertise is, and to show also his products and an implementation of his new project. Roger.
Thank you very much, Philip, for this introduction. And I'm very happy that I can share the information from Arobis with all of you. what we can do, what we do also in lab automation, maybe it's for you a benefit at the end if you can work or find solutions with our company in cooperation, and as well with a company from Philipp Osterwalder. We are cooperating a lot. So I try to share the window that we can have the presentation. So should we transfer this one? Hopefully everybody can see that. Is there something going on?
It's coming. Yes, I can see your screen.
Okay. So, let's start with Arovis, our company. We are in the base. Let's go over them. How can I go forward? Just make it. Okay. So go ahead. I don't know what is not working for the next step. So then I will share. It doesn't work, huh? So excuse me that.
Try to share again, Roger.
So I will do it the other way. You can see, hopefully like this. So
see your screen.
Yes, you can see the screen now. Our role is the company. We are in the base. We are distribution, engineering, and solutions company founded in 2017. Or around 8 employees plus, and we are a Swiss company, independent Swiss company. I have a short introduction to our company. As you can see, I'm the owner of Arovis. Arovis is automation, robotic, and vision systems, and we are the provider for smart lab automation. And we can use the frequent work with robots so that we can enable the power of the human to be a little bit more concentrating on their work, so the robot will help you to automate your system and your work through the day. And even if you are not, if you are on dinner or on lunch, your robot can work even ahead. So we are your partner for automation, robotic, and vision system. And so if you will come to our company and we have some techniques frequently, you can see also that we can work a little bit by fun with our Carrera race system. So what about a smart robot assistant? So we had developed a smart robot assistant, which means it's a platform where you can utilize with your existing equipment in your laboratory. We can do for you a integration. So I will show in the next video of how this gonna work. So with the Arovis assistant, we have an introduction that you can move your Arovis assistant with this movable platform to your workspace where you require to have more automation of it. You can see that pins we can fix, and now it's standing fixed on a position. Then we have also the keyboard and mouse holder, which is easy to install and ready to start with the robot. Even we have some hotels or also shelves which you could utilize, and with this one you could have a fully independent solution. Here we are as a customer solution where we integrated the ECO 555 into our scheduler. You see there the position code labels, and on the head, on the precise Brooks robot head, we also have a vision system, which on one system can recognize the positions of this plate handler for the ECO. Even he can also go and read the barcodes from the microtitle plates, and we can start a process. And now the ECO is the master, and he tells the robot that he needs a source plate. The source plate can be picked up by the robot, go to the regrip station, and can regrip from landscape to portrait, and then it places to the plate position of the ECO. And now the ECO will request a destination plate, which also has to be brought by the robot from the specific hotel position to its position at the ECO 555. And as you can see here, still the robot will do his work completely independent. So there is no need for another intervention by you. And it goes inside the ECO and does the work it is required for this plate. And if it's finished, then the destination plate will be picked up by the robot. And if it's required to have this plate also going to the bioshaker, which means it makes the bioshaking, then the robot will bring it to the bioshaker, and the bioshaker starts his shaking. And you can choose out of whatever you want, which program of the bioshaker has to be started. So by this Ruiz assistant, then the plate has been finished and will be placed back into this position where it was before. For sure, you can also utilize different kind of places where you want to place the plate after the session. And also the source plate will be brought back to the hotel. And it's a very easy scheduler which we built up with that. So the scheduler can be utilized by everybody who can be trained within 1 hour. So it's more like a configuration of where are the plates, sources and destination, and then the end of the equipment from the ECO can be utilized. So that's the introduction to the our Ruiz assistant, which means the Ruiz solutions we are doing automation solutions have different various kind of solutions, but one is the Ruiz assistant, and these are built out of our product lines. Means on the one hand we have robots, on the other hand we are specialists in vision systems. We bring them together to enable the engineers to be ready for other challenges in his projects. So the long-term experience within robotic vision systems and automation enables us to go into the different kind of projects. With Brooks Precise Flex 400 collaborative plate handling robot, we have a various range and also have the opportunity to bring the robot range expanded by a rail to existing system. As interface, we utilize a process management system, CELA Master, for example, or what also Philip explained before, we can also use the robot pilot and from OneLIMS. The system is developed for lab automation and industrial plate handling. As well as you have seen in the video, the microtiter plate, landscape, and portrait. So both is possible to utilize in that hotel. And we also can bring that together, that you will have a carousel, a rotating hotel system. Or we have also done several customized solutions. So what the customer wants to have as hotel or shelf, we can bring it to the market for him. Here again, the Arobi scheduler process view, you can see it's more like configuration. Where is the plate present? The barcode can be read. Which is the user who is working with, and also other kind of systems which we can have a very small scheduler into this system. Position training is very easy if it's required. If you have the position labeling enabled, then it's just required to teach in the platform with the hotels which you move, and the rest is then done automatically by recognizing the position code at your equipment. So that was the start which we made several years ago, and then there were new requirements coming up. And we built, which meant the Arovis Mobot is an improved efficiency system within labs, which means we have the workstations, we have safety, we have the OneLIMS process management execution systems, and we have several movable robots which can be processed by FlottenNature and Arovis Assistant, and even there we have the possibilities also to have everything in the cloud or utilize your interfaces you need in your companies. So Arovis Mobot workstation, what does this mean? So as far as you have seen before, is Arovis Assistant, which we now can underneath place a movable robot and pick the whole system fully automatically, which means it's not a human anymore which brings the robot to another working position. Now the robot can pick up, it's not a pickup, can plug the Arovis Assistant and move it to a new working space and work then next step. So it means we can integrate as well your or other robots. Preferred we have our robots, which we still have integrated, but if you wish to have your own robots to be integrated on such kind of a platform, we can do it. So what is then the idea behind such kind of a workstation with robot and lab equipment? The benefit would be that you can move your equipment close to the robot or to the sample handling system. And if you can imagine, you have an incubator where frequently, once a day, normally you have to scan all the microtiter plates which you have in the incubator. Then the robot can be placed next to the incubator, pick the plate and move it and transfer it to the screening system or to the pipetter or whatever you want to do with your samples. And this is fully automated solution. And the Arovis Moment, which means if you only want to have a mobile robot directly on the movable system, we also can build up that. We call it then mobile manipulator. Mobile manipulator is then also a customized solution if you wish. So we can not only transfer microtiter plate, but it's imaginable also that you have then a small mini incubator on the robot itself and moves from one place to the other. We work underneath with the Omron HEV. And therefore, you have the safety rated main laser, which is on the Omron itself. But if you build on top such kind of systems like robot or what else, then it could be maybe a safety reason. And therefore, the request was, how could we do and make it more safe to work with a robot so that the human does not care about robots? It should be the other way around. The robot should care about if there is human in the room. And we found on the market research that there is an existing radar sensor, which is also by the regulation and safety regulation free to utilize. And we built that, our Rovis Mobot, with that radar sensors. What is then the big advantages if you have this kind of radar sensors? I show you by a video what is then the opportunity you get. So hope you can see also this video now. Please something.
No, I can't see it, Roger. I just see the Rovis Mobot safety.
Not working. Sorry.
Just see the presentation.
I have to share this separately. Let's try again. Okay. So it should come in a few seconds.
Vimeo, yep.
Yes, now you can see.
Yes.
These are industrial mobile safety radar equipment system. Comes from the industrial side. It's not from lab, but it can be utilized. And just to explain you how this works, you will have few of these radar sensors in your room, and as soon as something is movable and the radar can detect this, then he can see and stop the robot working. And if you have a man inside the region of radar, it would not work. If he can detect, okay, there is no human anymore, then the robot will be enabled to work. As you can see in this video, there is a human in the range where the robot wanted to work. This is more like we utilize it in the lab automation system. And as soon as the man is gone, then the robot can pick, and he is now allocated with new radars all around himself that you can see, okay, there is a safe zone where you can work. Okay, this was the other one. Just let me check that I have the. Yes, here you can see.
I just see a white screen right now.
No, it doesn't work. I just have to restart.
Yeah, please reshare it.
Okay, just a second, then it will work again. Okay, just to see that there are 100 different ways to integrate the radar sensors. And you can imagine maybe you can have a fully room with this sensor, and then you can just make the range which you want to make sure that it is not allowed to have humans all around the robot. It works like this. So as you can see, now the human is going around, and the radar sensors are looking for, is it stop, or is it safe, or is it close, or is it not close? If it's in a range where you have the too close, then the robot has to stop. If it's in a range where the robot still can work, but human is not reaching the robot, then he works very slow. So there are different zones which you can implement into this system. And now you see the robot is going to fill up a pallet on the right side, and as soon as he wants to work on the left side, he detects, okay, there is somebody in the and it's not a safe zone, so the robot cannot work. So the lady has to move away, and then the robot can work again. So that's what I wanted you to show, that you can see these are solutions with radars. So, and again, I'll go ahead with my presentation. Yes. We also have a movable system, so which you can utilize for box moving system. So we can build box moving systems, also very independent systems that you can utilize it. And as I explained in earlier, before, the floater manager, which means they can manage different kind of such robots. You can imagine that these robots has to be managed. So, how is this robots in the real life working? So we have a short video that I can show you how this robot will also be working. It's a mobile robot who can at the end also plug and pick the system. Here you see without the covers of it, and maybe in this video you can see how it really works. That's why we did not cover it. You see these two pins on top, these white two pins, and he goes underneath this table, and on the table there is the other plug parts where the robot can move in, and then these white pins move outside and the system is picked. And you see he now has picked the platform to move it to another position. He can look around with the camera which we have on it, and then place it on a position. You can imagine it could be next to a equipment, and then the robot has done his work for moving the system. Last but not least, we can build our own lab automation solution for your smart lab. I mean, we build actually lab furniture solutions, standard and customized, which means we can utilize the robot Precise Flex from Brooks with rail integrated. Here on that picture you see two of these robots, and we have all the furnitures where the equipment is on. we develop for you, and we have such kind of standardization with different kind also of aluminium systems like Eaton, like Bosch, like Scania, and can then build your equipment, the system for your equipment especially. There is interfacing in hardware, software, connection to power, and flexible required equipment can be placed and utilized. And customer, that's very important, can use his management execution system or his LIMS if he wish. We are gonna try to make the interfacing that you can utilize your own system. But if not, we can help you by the integration or with your lab pilot from OneLIMS. And here you can see as well, all this equipment is movable and can be docked, because there are all the equipments are on rolls, and there are docking stations where you can fix or move the equipment through the robot base and will be plugged in. If you want to have more details about it, do not hesitate to ask us how we have done it. And here you see also some more pictures of our real robot, which we have in our laboratory in Neurovis in Alpnach. So, thank you very much for your time. It's a lot of information, I know, but there is a lot of innovation also all behind. And I think the future is for the lab automation is very challenging, but we will have this solution and part of the solution. And let's work together. Thank you very much for your time.
Amazing. Thank you very much, Roger, for this introduction and also presentation about your robot fleet and hardware and also innovation, what you are doing. I want to complement your robotic hardware with a little input from our side related to the software part, which we are focusing on. And this is related to, you mentioned it already, the lab pilot. We are working together on a new product. We call it lab pilot. It's a lab execution system. And it's built up for fitting into the requirements of a regulated and compliant lab. And this is also based on the lab automation, which includes different kind of modules, where we have a gateway on site, which is already connected to different sources. Let's say what we see before, kind of a precise flex robot or a scheduler, which also Roger presented, or some devices or even sensors. There is in the cloud then a broker, a workflow manager, a workflow designer, and also a real-life dashboard to keep track on all of the information, data, and statuses of the different workflows and work steps. What we have on site is an online buffer, offline buffer, which can have a queue and buffers if there is no connection, which makes it a resilient setup. And in the cloud, there are individual step-by-step guides, like implemented methods, work steps, driveways, and so on, with priorities and manual intervention if this is necessary, as well as resource planning and the compliant audit trail. What you can do with such a setup is pretty easy explained. So there is a variety of usabilities in the laboratory to automate different workflows and even different sources. If we're talking about the ELN or document management system, we're talking about different LIMS systems, which are already implemented maybe in the lab, ERP system, or even manufacturing systems. Also implemented can be external databases or the private database, which is used in-house. Roger showed it already about the fleet, which we are deeply connected and work together with this collaboration between OneLIMS and Arovis to bring this lab pilot into real life, integrate different kind of schedulers. We focus right now on the Arovis scheduler, and to integrate the Arovis fleet, which provides then even more control and setup functionalities from the hardware side about the robotic and lab automation. If any one of you want to have more information about the lab pilot or any kind of robotics and hardware vision systems from Arovis, from Roger, just send us a request email to hello@onelimbs.com. Now I want to close this with a real-life example, very quick. Also keep an eye on the time. I want to show you what is possible with a real-life case about automation workflows. To be aware of, this is just about the software part, not included with kind of robotics and custom workstation or portable workstations, what Roger showed before. We're talking about here about the quality control laboratory, which is into a method of checking purity of pharmaceutical substances. This is kind of HPLC method, and the average process of one sample takes roughly 90 minutes. This is kind of the sampling, sample preparation, labeling, the data management, measurement, evaluation of the data of the chromatograms, and also creating of the report. We have here in this validated method roughly 5% error rate, and the lab team can do 50 samples per day. That was the max limit about this. And they wanted to have an automation on software integration and to have several steps which can be automatically proceed. What we did so far is a transition of the automation. So first of all, the system setup of about a full integration. And the full integration means between the HPLC software and OneLIMS platform for integration, and also the implementation onboarding of the systems beforehand with training. This was all done, these two steps, within 3 months. And what we reached so far was an decreasing of the average processing time to have a processing time per sample of 30 minutes and 0.5% error rates still left. And we increased the sample throughput per day to 120 samples for the lab team. And this is going to a processing time per sample about 67% reducing of the sample time itself, increasing sample throughput of quite 2.5, and also the decreasing of the error rate by 90% through integration and also automation, the main steps. This leads overall to a reduction of costs related to overtime for the lab technicians, employees, lab team, and also the error corrections afterwards. So this is some real-life example what can be done with just a simple automation on the software side, and if it's going further for more technical wise and hardware with robotics related to the inputs from Roger. I want to close this with the Q&A and the outlook. From our side, check out our next webinar is related to Metron and an integration to Omnis devices, transform your lab into a connected digital ecosystem. You can also scan the QR code to get directly to more information or to save your spot. Second point is the Future Labs Live, end of June in Basel. This is a convention. We will have a booth there, and you can join our keynote or even join the convention. If you need any kind of tickets, just DM us or DM me directly on LinkedIn. Last convention is the Swiss Automation. It will be at the 12th of September, also placed on the Lake of Zurich in Rapperswil. We also have a booth there and a keynote about lab automation. Now let's come to the questions. Let me check in the comment section if there are any kind of questions. Yes. Okay, one of the questions is going, I think, to Roger. What kind of the key elements of lab automation for you, out of your advice, your expertise and experience?
Yeah, that requires normally also to the application we have to fulfill, but most of them is the precise robot from Brooks, which led us to enable making this human replacing system. So it means we have on the precise robot a TCP/IP server, and this enables us to make a very good interfacing. Hopefully this will answer the question.
For me, it's okay. If there is any follow-up question, just type it in the chat. I have get another question. Is what kind of lab industry you are collaborating the most, you're working in the most? Which kind of your hardware, your robotics you show, to which kind of lab industry this belongs to?
Yeah, it's more, most of them goes into research and development part of pharmaceutical companies.
Okay. Also, an expertise or experience in other lab fields like biotechnology, also usable and possible?
Yes, it's possible also to utilize there, but there is not that much. But yes, we also have requests on that.
Okay. Another question is, how do you proceed or set up a project for a lab automation to deliver and implement hardware and software parts? And what kind of your working steps?
So that's more or less as you explained also in your presentations. We're gonna start a project by visiting a customer, and he has some requests of how could I may have an improved productivity or to improve something in automation. Most of the time they still have their equipment or which they do handle by hand, and then they ask how could we do a implementation of a productivity improvement. And our system is in between a high throughput system and the human who does his few samples by the very beginning of a project. And therefore this system fits very well, and then it can grow up to as you have seen in my presentation, up to they want to have the furnitures and all the equipment integrated and to be connected hardware-wise by this precise flex robot. And even you could imagine maybe there is, if you have an implementation and then you want to have to expand it. And most of the time they start with a pilot project, and if this works well, then it expands into these companies.
Okay, got a good overview about your procedure and approach, how you're going to implement. We have one last question related also to the time. The question calls, does the robotic application by Arovis require the lab technicians to be trained in robotics, or does the provider Arovis handle that?
So the system is built up that at the end there is not an engineer or a expert required. Our robots are fully integrated, and the design which we work together with the operators is in a way that we can train it like you train your oven at the home. You can train it like this. So it's not required, but in certain cases, if you want to have new systems trained in, then for sure the equipment and devices has to be firstly integrated into the software part. But as soon as the devices are are in, then not necessary anymore to have engineers, robotic experts.
And what I can see from our expertise and also from our collaborated projects, we deliver workshops and trainings based on the software, and also Roger delivers some trainings based on the hardware that he's deliver. So if there is no knowledge or less knowledge to use the new equipment based on hardware and software, we provide those trainings and knowledge. Okay, hope this question is answered so far. My personal last question, when is the next Carrera race? Which I can share.
As soon as you visit us in Altenach, you get it.
Nice. Looking forward to.
Hope to see you here.
Very cool. I will let you know, Roger, for sure.
Yeah.
Nice. Okay, and already done. Time is already overdue. So hope you had some valuable information can took with you. Even if you have more questions, just let us know. If you want to connect on LinkedIn, just scan the QR codes from myself or even from Roger. Otherwise, thank you very much for your attendance and your time, and looking forward to our next webinar. Thank you, Roger. Thanks very much for your presentation and input. Looking forward to our next meeting and also to our continuous projects. Wish you all a good day and see you soon.
Bye.
Bye-bye.
Bye.
Just give me a sec.